All right, we're in section 14.2 where we're going to translate and reflect uh, uh, trigonometric functions. So in 14.1, we looked at being able to graph the three trig functions: sine, cosine, tangent, and that was when there was no translations. There was no horizontal or vertical shift when it came to those types of problems, which meant that we were trying to look for the basically the minimum and maximum of each of the values of the trig functions, and then the x-intercepts of the trig functions. What changes now is basically you're still looking for 5 key points, but you are now, instead of looking for um, x-intercepts per se, now you're going to be looking at what is called the midline of these trig functions, because now we're moving away from those key points off of the x-intercept, and it's somewhere else depending on the shift of the values of h and k. A lot of things still remain the same. Uh, the amplitude of the trig function is still going to be the value of a, here and here. The period is still going to be represented by finding 2 pi over b. And uh, here is the different types of key points that we're looking at depending on if we're looking for a sine function or a cosine function. So here, looking at our midline points, if you have a sine function, there's going to be 3 of them. When there's a translation, it's going to be for sine, it's going to be first coordinate is h comma k. The second coordinate is going to be 1/2 times it by the period 2 pi over b. Once you multiply that, then you add it to h, and then it gets a comma k. The third point is the period added to h comma k. For the minimum value of sine, you have one value, and that just so happens to be 3/4 times by the period plus h, and then it's going to be comma negative a because it's the minimum value plus k. The max value is 1/4 times it by uh, the period plus h, and then comma whatever the amplitude is, a plus k. If we go into cosine, now, there are 2 midline points. First one is 1/4 times by the period plus h comma k. The second one is 3/4 times by the period plus h comma k. We have one minimum for cosine, which is 1/2 times it by the period plus h comma negative a, because it's amplitude a plus k. And then the final one, the maximum, there's 2 in the cosine, which just like what it was in 14.1. It's going to be h comma a plus k, and then the period plus h comma a plus k. So what we have to do when it comes to graphing these, first things we got to do is be able to figure out, all right, what the period value is. Once you do that, establish what the amplitude is, so we got to figure out what a equals. And then if there is a translation, we got to figure out what h equals and what k equals, and then implement it into those formulas up on top. Okay, so first things first, I'm going to draw the midline. All right, the midline is told here. It says in order to draw, it's going to be y is equal to k. So y is going to be equal to, in this case, the value of k in this problem. So we're going to look at y is equal to 1/2 times it by the cosine of 2x minus 2. So because I got the minus 2 on the outside, there's no parentheses. K is -2, which means since there's no parentheses, that means in this particular instance, h equals 0. K equals -2. All right, a in this case is 1/2. So if I draw here, go down to -2, I'm going to say that this is my -2, and I'm going to draw my midline. Okay. Next thing we got to do is figure out what the period value is. The period value comes from 2 pi over b, and in b in this case is the value of 2, so it's going to be 2 pi over 2, which equals pi. So anytime we have these values here, the 2 pi divided by b in these formulas, in this particular problem, we are going to attach it with a value of pi. So since the period is pi, what I'm going to do is I'm just going to put pi over here because that'll be my value for my period. And I'm going to break this up. Here I got pi over 2. I got pi over 4. And I have 3 pi over 4. So hopefully, you know, using these points here, we'll be able to figure out coordinates for these particular problems. So first things first, I'm going to look for the midline coordinate. So there are 2 coordinates when it comes to respect to cosine. So I'm going to look at my midline points, and those are going to be points that are on this line that I just drew over the -2. So midline coordinate number 1 is going to be 1/4 times it by the period, which is pi. So in this case, it's 1/4 times it by pi, which is 1/4, added to h, which is 0. So my x coordinate is pi over 4. K is -2, so I go right here, -2. The next coordinate is going to be 3/4 times it by the period. So 3/4 times it by pi is 3 pi over 4. And k is -2. Next we got to do is look at a minimum. And in this case, there's only one minimum when it comes to cosine, and that is 1/2 times by the period, which is makes it pi over 2. Since there's no h, my x is going to be pi over 2, comma, negative a, so it's going to be negative 1/2 plus a -2, so that's like negative 2.5. My max is, there's 2 of them. The first one is h, so h is 0, comma, a plus k, so it's 1/2 plus -2, so that's negative 1.5. And then my other max is going to be simply 2 pi over, so it's the period, which is pi, comma, a plus k, so that's negative 1.5. All right, so we found all 5 key points. So now we get to plot them. So I have pi over 4, -2, which is right there. I got 3 pi over 4, comma, -2, which is right there. My minimum is pi over 2, comma, -2.5, we'll say is right about there. And we got 0, comma, -1/2, we'll say is right about there. And then we got pi over -1.5, so that say it's right about there. So drawing this out, looks like it's going to start going this way, come up to here, and then go here, and then it would just continue on as a continuous trig function. Okay, so that is graphing that particular function. So just like it was in 14.1, I'm more concerned about you figuring out these 5 points than necessarily getting the graph down. You can easily get a graph on your calculator, but being able to establish what those main points are is what we're looking for. So if we look at the next example, I got y equals 2 sine times it by 1/2 by the quantity of x minus 4 pi. So a in this case is 2. H in this case is positive 4 pi. There's no value of k on the outside, so k is 0. Let's see here. B is 1/2. So if when we look at the period of this, it's going to equal 2 pi over 1/2. 2 pi over 1/2 is going to be equal to 4 pi. Okay. So kind of get you an idea. Let's do this. We have for sine, we have 3 midline points, and since k is 0, my midline is right here on the x-axis. So you don't necessarily have to draw it because it's already established on there. So from here, the first midline coordinate with sine is h comma k. So in this case, h is 4 pi, so this is going to be 4 pi comma 0. The next one is 1/2 times it by that period, and this period is also 4 pi, so that becomes 2 pi, and then we add it to h, which will make it, so 2 pi plus 4 pi would be what, 6 pi, so we got 6 pi comma 0. And then finally, the last coordinate is the period, which is 4 pi, plus h, which is 4 pi, so that gets us 8 pi comma 0. So those are those 3 midpoints. Next is the minimum. And the minimum is, with the formula, is 3/4 times it by 4 pi. So 3/4 times it by 4 pi is 3 pi. 3 pi plus h is just 4 pi, so that's 7 pi. So now I got 7 pi comma negative a plus k. So there's so a is 2, so negative a would be -2, and there's no k, so it's just going to be -2. And the max value is going to be coming from 1/4 times by the period. So 4th times by the period in this case is pi. Pi plus h is what? Pi plus 4 pi, which is 5 pi, comma a, which is 2, because a plus k, but k is 0. So my largest x coordinate looks like it's 8 pi, so I'm going to use 8 pi here. So I got, so it looks like I got what? 4 pi right here. I got 2 pi. And we got what? 6 pi, 2, 4, 6, 8. All right, so looking at this, plotting points. First I'm going to plot is my midline points. So my midline points are going to be 4 pi comma 0, 6 pi comma 0, and 8 pi comma 0. Next is I'm going to plot my minimum. My minimum is, so I'll just put -2 right here. I'll put +2 right there. It'll be, what, 7 pi? So it's going to be right about there. And my maximum is at 5 pi, and that'll be at 2, which would be right about there. So my my function is going to be right about there, and then I can just continue on by saying, like, it's probably going to look something like this all the way across. Okay? And we got one more on here on the bottom. So this one is y equals negative cosine 4 times by the quantity of x minus pi over 4 plus 1. So this is a situation where now we have h and k as values here. So a is a negative 1 in this case. So with respect to sine and cosine, now it gets like a mirrored image version of it. So h is positive for pi, k is 1. My period for this function is going to be 2 pi over b, which is 4, which equals pi over 2. So period is pi over 2. And it's cosine, so there's two midlines. There are one minimum and two maximums. So I'm going to draw the midline, so it's going to be y equals k, so it's y equals 1. So I find 1 here, and I draw my midline. Next, I'm going to find those coordinates. So my midline points are going to be, so first off, it's 1/4 times it by pi over 2, which makes it pi over 8. And then pi over 8 plus pi over 4 will get me 3 pi over 8, comma, k, which is 1. The next one is, we got 3/4 times it by the period, which is pi over 2, which gets us 3 pi over 8 plus h, which is pi over 4. So now I get 5 pi over 8, comma 1. My minimum comes from, is going to be 1/2 times it by pi over 2, which is pi over 4. Pi over 4 plus pi over 4 is going to be pi over 2, comma, and this will be negative a, so negative a, so that's actually going to be positive 1. 1 plus 1 is 2. So my minimum in this case is actually going to be my maximum because of that negative amplitude. And my max is going to be, um, so it's just pi over, it's going to be what, pi, oh, it's just going to be h. So h is pi over 4, comma, a plus k, which will give us negative 1 plus 1, which is 0. And the other max, because there's two of them, we're going to have the period, which is pi over 2 plus h, which is pi over 4, which gets us 3 pi over 4, comma, and this will also be 0. So to look at this, looks like I'm going to start, my largest value of x seems to be 3 pi over 4, so I'm going to put 3 pi over 4 here. I'll go 3 pi over 8 here. I have, looks like pi over 4, pi over 8. I have what, pi over 2. And then we got 5 pi over 8. So looking at the first one, our midline points, so we got 3 pi over 1, 3 pi over 8, comma 1, and we got 5 pi over 8, comma 1, which is here and here. My minimum is pi over 2, comma 2, so I'll just put a 2 over there and write that right there. And then my maxes is going to be pi over 4, comma 0, and then 3 pi over 4. So my function is going to look something like this, and then kind of continue on, so it looks probably something like so, and continue on from there. Okay. Just like yesterday when we talked about tangent, all right, still it's going to be the same general equation. It will be y equals a times it by the tangent of b times it by the quantity of x minus h plus k. All right, it's the same thing as the translations for sine and cosine. Remember that we have asymptotes that we're trying to keep in mind. Same idea for those asymptotes values. To find the period for each of these is still the pi over b. We're still going to draw out a midline point. I still want to make my asymptotes. I want to do that as vertical dashed lines. And I'm looking for those halfway points. All right, the halfway points are pi over 4 times it by b plus h, comma a plus k, and then negative pi over 4b plus h, comma negative a plus k. So looking at this problem here, figuring out that in this case a is negative 2, b in this case is 1, and h is pi over 2, and k is negative 1. So looking at drawing the midline is the same as it was in the previous pages. It's y equals k, which is negative 1. So I find negative 1 here, and I draw my midline, okay? My period for this function is pi over b, which is 1, so it's just going to be pi. So I'm just going to put pi right here. I can even put 2 pi to illustrate another one for us. And then I want to be able to draw the asymptotes. So in this case, they're going to be vertical asymptotes. So the asymptotes here are as follow. The first one is going to be x equals, in this case, the period, which is, or so it would be pi over 2. Pi over 2 plus pi over 2 in this case, because h is pi over 2, so we get x equals pi for one asymptote, and the other one's going to be x equals negative pi over 2 plus pi over 2, which is 0. So this one is my first asymptote, and then the second one is like so. My halfway points come from the first coordinates are going to be what? Pi over 4b, so it's going to be pi over 4 plus h, which is pi over 2. So that gives me 3 pi over 4, comma, and then it's a plus k. So a is negative 2 and k is negative 1, so that gives me negative 3. So that's my first halfway point. My second halfway point comes from negative pi over 4 b, which in this case will be negative pi over 4. Negative pi over 4 plus pi over 2 is positive pi over 4, comma, and then we get negative a, which would then be positive 2. Positive 2 plus negative 1 would be 1. So plotting those points, so we'll say that if this is pi over 2, so we got 3 pi over 4 over negative 3, we'll say is right about there. And then we'll say that pi over 4 comma 1 we'll say is somewhere over there. So when we are constructing this here, it'll look like, so, and if we had more, it would look something like this. Okay? And that is being able to translate and reflect trigonomic functions. Hope this helps. Until next time.